Good morning everyone. Today we'll discuss about sigma and pi bonded organometallic compounds. So why are we discussing, what is the need of discussing organometallic compounds? Because in your portion you have metal carbonyl compounds, okay? And you know carbon is considered as the member of organic compounds, or indeed all organic compounds are made up of carbon. So when there is an association between the metal atom and the carbon atom in any of the ligands, for example, here we are taking the case of carbonyl group, that is carbon monoxide acting as a ligand. So such type of compounds are classified as organometallic compounds. There are various other organometallic compounds which do exist in nature, but here we are just discussing about metal carbonyl compounds, right? So one very important thing to be noted down over here is that the oxidation state of such compound is 0. So here we have the geometry of various types of organometallic compounds that basically I must restrict to the term metal carbonyl compounds. So the first one goes as tetracarbonyl nickel. So it is tetrahedral in geometry because the coordination number is 4, as it is clearly seen over here. The next one is hexacarbonyl chromium, that's with octahedral geometry as shown in this figure. Otherwise we also have pentastate, right? So we can easily see when the coordination number is 5, the geometry is going to be trigonal bipyramidal. And we have already learned before that 3 of the carbonyl groups will be arranged in equatorial position and other 2 will be arranged in axial position as mentioned over here. Okay. Now apart from that, we have some bridging carbonyl compounds and polynuclear carbonyl compounds as well. So here you can see the structure in which there are 2 manganese as a central metal atom, and each manganese, since there are 10, that means there are 5 ligands around it. So each manganese carries 5 ligands over here. This set also carries 5 ligands around here, and there is a bond between manganese, that is metal bond, wherein when you see the bridging carbonyl compounds, the 2 metal atoms are linked with each other, but apart from that there is a carbonyl group which acts as a bridge between the 2 ion as a metal atom, central metal atom. So these are the structures which you need to learn, okay? Now we further will discuss about the bonding existing in such type of complexes. So here we are set with it, metal carbon bonding in carbonyl complexes. So it's very important to understand that in such type of complexes there are 2 types of bonds. One is the sigma bond and the other one is your pi bond. So how is sigma and pi bond formed? Let us understand it very clearly. So as I said, CO, that's carbonyl group, is acting as a ligand, and throughout the coordination chemistry we have already understood that ligands are going to donate lone pair of electrons to the central metal atom. So when they donate the lone pair of electrons to the central metal atom, it results in the formation of sigma bond. So from where do you get these lone pair of electrons? So these lone pair of electrons are from the carbon atom, which is a part of carbon monoxide molecule. As I told you, the formation of carbon monoxide molecule would be totally depending on the concept of molecular orbital theory, which you have already learned in grade 11. So according to molecular orbital theory, there is a participation of bonding and antibonding orbitals. So the lone pair of electrons which is present in the carbon atom, okay, in the orbital of the carbon atom, in this molecule, when donated to the vacant d orbital of the metal atom, it results in the formation of sigma bond. I repeat again, the lone pair of electrons which are available in the orbital of the carbon atom in carbon monoxide as a ligand is donated to the empty or the vacant d orbital of the metal atom. So it's very clear over here that the sigma bond is formed due to the donation of the lone pair of electrons from the carbon atom of carbon monoxide or carbonyl as a ligand to the vacant d orbital of the metal atom. Okay, so this is what is highlighted here. Now likewise, what is the formation of pi bond over here and why it happens? So what happens, there are also the filled electrons in the central metal atom, that's the d orbital. We have already understood the process of hybridization in case of metal complexes or particularly metal carbonyls as well, with the help of valence bond theory. So according to that theory, how the pairing occurs, how the pairing of electron doesn't happen, all that will decide the number of electrons sitting in the d orbital of the central metal atom. So the orbitals of the metal atom, that means I'm talking about basically the degenerate d orbitals. So here we also understood that degenerate orbitals is going to split in the form of T2G set and EG set, and the pairing depends upon the nature of the ligand. So from those paired d orbitals of the central metal atom, the electrons are being donated to the pi asterisk, that means the anti-bonding orbital of carbon monoxide molecule, right? So anti-bonding orbital which goes for the carbon monoxide molecule will take up the electrons from the metal atom. So when it takes up the electrons from the metal atom, it is called as back bonding. Okay, so pi bonding is also known as back bonding. So very clearly make a note of it. Sigma bonding is a usual bonding from the ligand towards the metal atom in the, of course, the empty d orbital of the metal atom, whereas the pi bonding is from the metal to the anti-bonding orbital of carbon monoxide molecule, which is acting as a ligand. So here we have clearly mentioned, see here in this figure, that metal atom donates the electrons to the anti-bonding orbital of the carbon atom. Okay, so that's result in pi bonding and sigma bonding. I have already explained you before. Now these two planes are perpendicular to each other. Okay, this will be clear to you when I'll show you the 3D model of it. Okay, I'll be sharing the 3D model as well. And very important point to be noted down is this pi formation, pi bond which is formed, is also known as back donation from the metal atom to the carbon atom, which is a ligand basically, and this effect is known as synergic effect. Why is it called a synergic effect? Because there is a strengthening of the bond as the ligand donates the lone pair of electrons to the central metal atom, but additional to it, the metal atom also donates its electrons from its d orbital, which carries the paired electrons to the vacant anti-bonding orbital, to the ligand. Hence the bonding becomes pretty strong over here. And the factors which will stabilize the bonding and strengthen the bonding is basically due to back bonding. So this back bonding concept I have to share with you with a 3D model. So keep watching and we'll be understanding the 3D model so that you understand how the orbitals merge, how do they share, and what exactly is meant by synergic effect. So keep watching. Yes, children, we are going to see the 3D model of the formation of sigma bond and the pi bond. Now in this figure you can see how closely carbon monoxide as a ligand approaches metal atom to donate its lone pair of electron, and that's the sigma bonding. Now when we talk about the formation of pi bonding, it's just the reverse, which is the back bonding. The metal atom approaching close to the carbon monoxide molecule, you can see here, and giving its electron to anti-bonding pi orbital. Now this is very clear, and this effect, what I told you, is called as synergic effect, where the sigma and the pi bonds are perpendicular to each other. Henceforth, the carbonyl compounds bonding is very clear to you, and make a note of all the structures so that you can easily understand it. Thank you all.